Hey everyone and welcome back to another tutorial. In this one we are going to discuss doubly linked list. That's going to be an interesting one to teach and also to understand. If you don't know about me, I'm Ahsan and I'm a Google acknowledged Google developers expert in Angular, and this is part of a series of my data structures and algorithm playlist. So we have already discussed about a couple of data structures like stack, queue, linked list, and this particular video is essentially a sequel of the linked list one. So if you have not watched the video of linked list, I would highly recommend that you go and check the linked list video first, because this one is going to be based on that. So without further ado, let's get started. So first of all, let's have a look at what the application looks like, because I like to keep my tutorials built in a way that they are visual and you can actually see what's happening along with the JavaScript itself. So this is how a doubly linked list looks like. In a doubly linked list, we have multiple items and each item has two pointers. The first item that you see here, which is the head, essentially points back to null. This head also points to the next item, which means that this next pointer is essentially pointing to this item, and the next item then points back to the previous item, just like this. So you see that these pointers are essentially the previous and next. Similarly, this 33 element is pointing to the next item, which is this ABC, and this ABC would point back to 33, and this goes on and on and on. Now there are some things that you need to understand about a doubly linked list. Since they're based on the linked list, they always go from head to tail, which means that we essentially start looking at the first item, which is essentially the head of this linked list. The tail of the linked list means the last item. So we know that the head is going to be the first one and the tail is going to be the last one. Now apart from this, we also know that a doubly linked list would have its head pointing to null, which means that it will not have a previous item. Similarly, the tail would point its next pointer to null, which means that the final item or the last item in a doubly linked list points its next pointer to null, which means there are no further items in this particular linked list. And that is essentially how we identify the end of a linked list or the beginning of the linked list, and also the head and the tail of the linked list as well. So I hope this makes sense now. Since this doubly linked list is based on linked list implementation, we already have some functions working. Some of the functions are not quite accurate, so we are going to implement those. But let's say if we want to find out which element is at the index 2, we can use this getElementAt method, and we can provide the index here. So we can say, let's say 2. Because the indexes start from 0, so it's going to be 0, 1, 2. So if I say OK, you can see that the retrieved item here is ABC. Similarly, I could try to find a particular element and see what is the index of that element in this linked list. For instance, if I want to find, hey, where is XYZ in this doubly linked list? So that's going to go here, and then we can simply say XYZ. And then if I try OK, you see that the index here is 3, because that is essentially the last item. So 0, 1, 2, 3. We can add items in the middle. We can also remove items in the middle. But compared to a linked list, if I go to the linked list example here, you will see that a linked list always has its next pointer to the next item. So it's sort of a one-way linked list. You could call it just like that. It doesn't point back to its previous item, or any item in a linked list does not point back to its previous item. Every item in a linked list just points to the next item. So you can see that the head is 22. The tail, we could call it that it's XYZ, but essentially we can just say that the head points to 22 and 22 points to 33, and this goes on and on and on until the last item is null or is pointing to null essentially. So this is exactly the same thing, but in this case we have every item pointing back to its previous item as well. And this kind of makes things a bit more complicated when we are to implement this in JavaScript. So if I open this, let's see what happens. I'm going to open this right now, and here if I go and check out, if I refresh here, you will see that we have this linked list. If I open it, you can see that the head is pointing to 22, which is this head. The tail is pointing to XYZ, which is this one. And then we can see the count here is 4, because we have 4 items. And if I open this head, I can actually iterate through every item. So I would start with 22 and go all the way to XYZ just by doing something like this. So I can say head, and here we have the element 22. This 22 points to 33 and points back to null. So you can see that this element is 22. The previous here is null because it points back to null. The next here is 33. Similarly, if I go forward and open the next one, you will see that this element 33, which is this one, points back to 22, right? So if I open this something like this, you will see that this 33 that we have, it points back to 22. It also points forward to ABC, just like this. So we can easily say that, hey, this is what's happening right here as well. So here you can see that this 33 is pointing next to ABC, which is this one, and it's pointing previous to 22. Similarly, if I open this ABC ABC, you can see that the ABC's next pointer is going towards XYZ. So the next is pointing to XYZ here, and the previous here is pointing back to 33. So from ABC, it's going essentially back to 33, just like this. And this ABC is pointing to XYZ as we just discussed. Now let's talk about how can we implement this whole data structure, the doubly linked list, into JavaScript. And for that, I already have a branch for you that you can check out. So let's quickly do that. So the branch that we are going to check out, we'll do just git checkout, and then we'll do dll-start, which means that we are essentially using the doubly linked list start branch. And if you don't have this project cloned yet, you need to go to the video description and you can essentially see the Git repository there that we can use for this whole project. So you should be good there. Make sure that once you have cloned this repository in your machine, you run the npm install command, which will install these node modules. And once you are done with that, all you need to do is just run the yarn start command, or you can run the npm start command as well. And this should essentially start the server for you. Once you've started the server, you can just control click here, and then you should be able to see that running in the browser. So in your browser, you're going to see a list like this, and all you need to do is just click the JS doubly linked list, and this is what we see. Now by default, you see that it looks quite like the linked list itself, or essentially it's nothing basically. It's not doing anything. Probably it's breaking because of some of the things that we have to implement. So yeah, that's fine. We don't have this function right there, so it's not quite there yet. Now let's talk about the push method first, because that is what we are going to build in this case. Now I'm going to go to GitHub, and then we are going to see what is the use case here. So I'm going to go to my GitHub, and then here we have fun with JavaScript, and we are quickly going to go and open this link here, which is doubly linked list. Now let's talk about what would happen when we add a new item into the doubly linked list. So imagine that a new item comes in right here, which is the last item's position. Let's say this item is called DEF, and that would mean that we need to do a couple of things. The first thing is that right now this XYZ, this is pointing to null. But when we add a new item, this next pointer should essentially point to DEF. That is the first thing. The second thing is that this DEF would have its back pointer, whatever that is. So its back pointer should essentially point to XYZ. That is the second thing that should happen. And finally, this def would have a next pointer as well. And that next pointer should point to null, because previously XYZ was pointing. Now this new item that we are adding, that should point. And one more thing that we need to do is to make sure that now the tail is not XYZ, it's going to be DEF. So we need to make sure that the tail is DEF. So let's make sure that this happens by implementing the push method now. So first of all, we are making sure that we are on the DLL start branch, and we need to extend our doubly linked list class, which you can go inside from source, projects, JS doubly linked list, and then doubly linked list.js from here. Now we're going to extend this class from the original linked list class, which is right here in this linked list file. So we already have this implemented with all the functions that we just discussed, like the push, remove add, get element add, and whatnot. So first of all, we are going to import a couple of things from this file. So we are importing the linked list itself because we are going to extend that. Then we are also including this default equal function, because when we try to find a particular item in the linked list, we use this equal function to compare those things. Let's say if I want to say, hey, get the index of the item DEF, then I would have to compare that somehow, and this default equal function is what does it. So if we open that, you will see that it's very simple. It just takes two arguments, A and B, and then compares them and then returns the value. So it's either true or false, and then that's how it works. Now we also have the possibility for the developer to essentially pass this function, and let's say if the developer is working with an object, then they can also pass their own equality function and they can implement the logic themselves, but this is the default one. Now that we have imported this linked list, we need to extend our doubly linked list from this linked list. Now you will notice that in the linked list file here, we have a constructor that essentially takes the equals function, and that is in the constructor, it makes sure that the head is null, the count is 0, the equals function is the default equals function or whatever is passed, doesn't matter. But what we are missing here is that in terms of doubly linked list, we also have something called the tail. So we also need to make sure that the tail is defined here, and then that is also set to null. So we are going to essentially write our own constructor here, which is identical to the linked list one. But after running the super with this equals function, which essentially just runs all of this and creates these properties, we also need to do something called this.tail equals to null. So we are setting, we also need to do something called this.tail equals to null. So we are setting the tail to null, right? Now let's talk about what other functions would be overridden in this doubly linked list. So I have a list of all the functions that we need to override. We would override push, insert add, and remove add, and we will also override the clear. Why do we have to override the clear method? Because this clear method, if we go here and try to find the clear here, you can see that it resets the head, but it doesn't reset the tail. So we can start with essentially this one. So all we need to do here is that I'm just gonna copy this one, gonna go here, and then all we need here is just the super.clear, and here we can say this.tail is also going to be null. So when we call the super method in JavaScript, that means that we are essentially calling the function of the class that we are extending. So if this is extending linked list, that means that we are inheriting all of the methods and all of the properties from the base class or from the linked list class. So when we call super, that means we are essentially calling this class's method. When we just call super in this constructor, that means that we are calling this constructor. If we are calling super dot blah blah blah, that would mean we are calling linked list dot blah blah blah. So here you can see that we say super dot clear. That would mean that we are doing this linked list dot clear, and then we can implement additional things as well. Now let's talk about the push method. So the push method has a couple of steps, as we discussed already on the view. So first of all, since we already know that we are going to have to change something related to the last item that we already have, which means that if there was an item that was to be added here, we have to also change this item, which is the previous item, right? So we need to get access to this item, so its next pointer can be set to the new item that we are setting here as a def or whatever item that is. So for that, we need access to that item. So let's get that first, and then we are going to do multiple things as well. So in our push method, the first thing that we need to do is get the previous item, and that we can get by the index. So we know that, let's say if there are 4 items in the linked list, then the last item right now is at the index 3, because the index of the last item is always size -1. So we can simply say the previous element is super.getElementAdd at this.size -1. This is exactly what we are doing. And this getElementAdd method is already implemented in the linked list, so we don't need to implement that, courtesy of object-oriented programming. Super cool. Now that we have got the previous element, we need to do some magic here. First of all, since we are adding a new item, we need to create a new node. And we do that by doing something like this. We do a new node, and then we do equals super.push, which means that we are going here and then we are using the push method, which does a lot of things, but essentially it creates a new node, which means that it's creating a new node with the element and the next. So we create a new element. Now the only thing missing here in terms of doubly linked list is that the next element is going to point to null, because that's the last item. It does not have a previous property here, and that is what we would have to implement here in our code. So we call the push method, it pushes this item to the end, and when it does, all we need to do is that we can say the new node's previous property is now going to point to the previous element, which is perfectly fine. But we also need to make sure that this previous element's next pointer also points to this new node that we just created. So that's what we are doing here as well. Now the thing is that the previous element's next pointing to this new node is something that is already implemented here in the linked list class, so we don't need to do that here. As you can see, this is what we are doing. So we are saying that current.next is going to point to the new node that we just created, so we don't need to do that here. Now the final thing is that whenever we push an item to the linked list, it becomes the last item, which means that now this is the tail, and that is what we are doing here as well. So let's save this and try this out now. So I'm gonna refresh this, and actually this is not the one, but this is my local host. So I'm gonna open my inspector here, and then I'm going to refresh, and now you see that we don't have the push error, and you can also see that we have some data here. Now as we discussed, we are going to push a new item to this whole object, and right now as you would see that the tail is XYZ, the head is 22, which is perfectly fine. The tail's next item is pointing to null at the moment, which means XYZ is pointing to null as the next pointer. Now if I push a new item called def. Let's see what happens. So I'm going to click OK here. Now you see that the tail label is gone from here because we got a new item, which is tail here. And now this item should have a pointer, the previous pointer, back to XYZ. So let's first check that out. We've got a new log with the latest state of the linked list. If I open this, you see that the tail now is def, exactly what should happen. This def's next item is pointing to null, which is what's happening. This def's previous is pointing to XYZ, which is what's happening. So this is perfectly fine so far. But one more change that we also did was we set this XYZ's next pointer to def because previously it was pointing to null. So if I open this tail and see its previous, which is XYZ, this XYZ's next should point back to def, and that is what's happening. You can see that this XYZ points to def, and that is what we wanted to achieve now. Now that we understand that, let's go back and implement the next method, which is the insert add method. So the implementation of insert add item is actually very interesting because it has a lot of use cases that we would have to discuss. The first use case is what if we add this item to the beginning of the linked list. The second is what if we do it at the end of the linked list. And the third one is that what if we add this item in the middle of a linked list between any two items. So let's see what happens here. First of all, we need to make sure that the index that we are providing is not out of the bounds, which means that the index cannot be less than 0 and it cannot be greater than the size. So let's discuss what that means. So this essentially means that the indexes here are 0, 1, 2, 3, and the size of this linked list is essentially 4. So if the index is less than 0, that would mean that it's either -1, that is a horrible -1, or it's gonna go above 4, which means that this could be 5, right? The thing here is that this is not okay because we cannot have anything at -1 index because the indexes start from 0, and we cannot have it greater than 4, although it could be 4. The reason for that is that if I say that right now we have 0, 1, 2, 3 as the linked list items, then I can add another item to 4, which would mean that we are doing something similar to how we do a push. That is what's happening. But if I say that it's going to be 5, that's a problem because we would not have anything in the middle and we would have something at 5. So that is not okay for us. So now that we understand that, let's go back to the code. So if that becomes the case with index, we need to return false here and we will not proceed with any further calculations. So let's talk about when the index is correct, which means that it's either 0 or the size of the linked list or something between them. So first of all, let's talk about what if the index is 0, which means that now we're talking about adding the item to the beginning of the linked list. Now there could be multiple reasons or multiple scenarios here, but first let's talk about that we are creating a new node because we have to push that node into the linked list. So we are inserting a new item at the index 0. So first of all, we create this new doubly linked list node, but we don't have doubly linked list node. So what we are going to do is that we are going to change this. So let's keep this right here, but I'm going to change this now. Now we also increase the count because we are pushing an item into the linked list. So the count increases itself. Now, if this is added to the first item of the linked list, which means that right now the head is null, which means that this linked list is empty. So let's discuss that case right now. So in my application, what I'm going to do is I'm going to clear this linked list, which means that now we have nothing. In this particular case, we have the head and tail both pointing to null. Now what should happen if I push an item or if I add an item into this linked list, which means that now I'm going to try to add a new item. Let's call it ABC. So this is an item that I'm adding right now, right? So this would have a back pointer and this would also have a next pointer. In this particular case, the next would point to null. Okay. The previous would point to null as well. So the previous is going to point to null. This becomes the head and this also becomes the tail because this is going to be the only item that is existing in this linked list. So how do we implement this now? So we are going to go to our code and here we are going to say that the head is the new node because the linked list was completely empty. In that case, we have this head pointing to the new node. We also have the tail pointing to the new node, which is perfectly fine. And when we create this new node, its next is already pointing to null because that's what's happening here. So if you see this new node's constructor has the next pointing to null by default. So we don't need to cater this next property. However, we are going to handle the previous property in our case. So before we go to any other condition, let's fix this doubly linked list node, which doesn't exist because I changed the code. So what we need to do here is that we are going to essentially do a super dot, or we can essentially get the node itself. So here with the default function, we can get the node, and here we're going to create a new node just like this. So we can say this is going to be a doubly linked list node, okay, node. And we can also in this particular case say that this new node's tail, or actually this new node's previous, is going to point to null. Why are we handling the previous one? Because we already discussed that the next is handled automatically, the previous isn't handled. So when we do this, our code is now ready to reflect the situation where we want to insert an item at index 0 where the linked list is absolutely empty. So we are going to get this checked out right now. So I'm going to refresh this. I'm going to go to inspect. I'm going to clear the console and clear the linked list first. So now you would see that the linked list has no items. The count is 0. The head is null, tail is null, and equal function is whatever we passed. But if I say insert add, then it first asks me what is the item that we want to add. So I'm going to say def and then the index. So if I say the index is going to be 0, let's see what happens. So if I click OK, you see that we got this item created in the UI as well. The head and the tail both are def. The previous one points to null. The next one points to null. But the UI does not matter. What happens in our data, that is more important because that's what you're going to use. So if I open linked list, see what happens. The count is 1, perfect. The head is def, really good. The tail is def, very good. And the tail has its next and previous pointing to null. And since the head and the tail both are exactly the same thing, then we have the next and previous pointing to null. So this is essentially what we wanted. Now let's talk about the second use case when we add an item to the 0 index, but there are still more items in the queue. So what would happen in that case? So let's say if I refresh and we already have some items in the queue, what should happen if we add a new item at the beginning of this linked list? So imagine that we are adding a new item here. We can call this 1, 2, 3. This is the element that we are adding here. Now this element would also have its previous and its next pointers, right? Now the changes required in this linked list are as follows. First of all, this head, which is right now pointing to null right here, is not going to point to null anymore. This is going to point to 1, 2, 3 because that's the previous item. This element 1, 2, 3's next pointer is now going to point to this item because that becomes the second item now, right? Because the indexes will now change. This would be 0, this would become 1, 2, 3 and whatnot. Now we have done two things. First, the current item or the previous item that was at the beginning is pointing back to this new item. The new item's next points to the second item, that is the change item now, and this items or the new items previous. Now this is going to point to null, right? Because previously this head was pointing to null, but now this one is pointing to null. And one more thing that we also need to do is that now that this is the first item, we also need to make sure that this is not the head, which is 22 is not the head anymore, but 123, this now becomes the head of this linked list. All right. So I hope that makes sense. So we need to do all of these things in the code now. All right. So we need to create an else statement. And here, first, we are going to say that this new node that we just created, its next pointer is going to point to the previous item or the current head, because current head becomes the second item and this new node becomes the first item. First item pointing to the second item. So you can see that this is the second item and this is the first item. Its next is pointing to the second item. Perfect. This current is now going to point back to this new node. So to the current dot previous equals to new node. And we also mentioned that now this new node is going to become the head. So that's what we are doing. The head is now new node, and that is all that we needed. So I'm going to save this and we are going to try this out now. So I'm going to refresh this now and I'm going to go and inspect, and we are going to follow the same example that we just discussed. So I'm going to say, hey, insert add, and then we are using the item 1 to 3, and then we are giving this the index 0, which means that this is going to be added right here. So if I say okay, let's see, you see that the head now is 1 to 3. This 22 is not the head anymore, and let's see the data structure as well. So if I open this, the head is 1 to 3. Amazing. You can see that this head's previous is set to null, which is what should happen. Next is set to 22, but we also need to make sure that this 22 is pointing back to 123. So if I open this, you can see that this 22 element is pointing back to 123 as it should, and this is what we wanted to do. So we are actually doing what was required in this particular use case. Now let's talk about the use case where we are adding an item at the end of this linked list. So what would happen in that case? Now this one is actually pretty easy. You would ask why, and I would simply say that if you're adding an item into the end of the linked list, that just means that you're pushing that item into the linked list. So that would mean that we are adding a new item right here, which is same as doing a push. So what we are going to do here is that we're going to go to our code and implement the same thing. So here in our code, we are just going to say that if the index is not 0, but the index is actually the size of this array or the size of this linked list. So let's say if there are 4 items in this linked list, that would mean that the index is now 4. That would also mean that so far we have 0, 1, 2, 3, which is 4 items. But now at the 4 index, we are going to add this item, which is just simply pushing. So we just say return this dot push element, and that's it. It's going to go to this push and going to do exactly the same, and we should be good with that. So I'm going to save this and let's try this out. So if I refresh here now, and let's say we do an insert add and we say the new item is going to be called ZZ2, and here I say the index is going to be 4. We already have 4 items in this linked list. So if I say index is 4, that means the 5th item. So if I say index 4, then that would mean that if I click OK, now you see that XYZ is not the tail anymore, but we just pushed another item ZZ2, and that is also reflected in the data structure. So we don't need to go too much into this. Let's jump to the next topic, which is the final one, and that would mean that we are not adding at the beginning or the end, but now we have to take care of a couple of more things. So let's discuss what they really are. So let's say we are adding a new item right here, and let's say this is an item that is called ZZ2. So that would mean that this new item is going to have a back pointer. It is also going to have a forward pointer. So let's say this is the forward pointer, this is the back pointer, and now we have to do a bit more work. And the reason is that since we are adding this at the middle of 2 items, then this whole scenario or this previous connection of 33 pointing to ABC and ABC pointing to 33, that changes now, because now 33's next is going to point to ZZ2. ABC's previous is also going to point to ZZ2 because they were previously pointing to each other. Now the ZZ2's previous is going to point to this element, which is 33, right? So it's going to do this, and this ZZ2, how funny is that to call it? This item's next is going to point to ABC. So now you can see that this is what we should do. We should set up these pointers and adjust the new node to also point to the correct items and kind of adjust this new item in the middle of these two. So let's do that in the code now. All right, so finally what we need to do here is that we are going to say that first we need to get the previous element. So we need the previous element and we need the next element, and then we are adding an item in the middle, right? So the previous element can be retrieved by just using this get element add method. So here you see that we are using index -1, which means that if this is being added at index 2, that would mean that the previous items which were at index 1 and index 2, they are both going to be required in this case because we need to have this one in the middle. So first we get the previous element, then we get the current element, which is the next item. So we also get that item in this index or from the same index, and now we are going to say, hey, this new node is going to be something that we add in between these two places. So let's imagine that we are adding something here. So I'm going to explain all of these lines, but let's imagine we had the items 1, 2, 3, and 4 here. Now if I add an item X in the middle, that would mean that we need to get this 2, right? And previously, let's see how that looked like. So in this case, if I remove this situation, we can compare them side by side. So now you can see that in order to add this item at index 2, because this is 0, 1, 2, 3, actually let's make this look like it makes sense. So 0, 1, 2, 3, 4. We're also going to do something like 0, 1, 2, 3, 4. So if I needed to add, let's say, a new item at index 3, what would happen in that case? First of all, we need to make sure that we retrieve this 2, and then we need to retrieve this 3. So here what we are doing is that we are getting this previous element by doing index -1. So we are doing 3 -1, 2. So we get this item first. Then we get from the index itself, which is 3. So we get this item as the second one, as the current variable. So we get the previous element as 2, current variable as 3. Then we add a new node at the index 3, which is being added here. So this is the step where this happens, that we add this X variable here. Now all is left is to point these things to each other. So first of all, when we insert this item into the middle, this 2 already points to X, and that is being happening already here in this linked list class. So we don't need to do that. You can see that here we say previous.next equals to node. We don't need to handle that. What we need to handle is is making sure this 3 points back to X. So that's what we do. We say current.previous equals to new node, which means that this current 3 points back to the new node. Then we also make sure that this new node that we just created, this new node's previous points to the previous element. So this X should point to 2. That is what's happening here. So we are saying new node's previous should point to either the previous element or it should point to null if the previous element does not exist. But you can see that that's working here. And finally, we just returned the new node. So that would mean that all of this essentially was successful and we don't have any issues whatsoever. So I'm going to remove these logs. I hope you understand this whole concept. And now we are going to try this out. So we are going to perform exactly the same example that we discussed. We are going to add an item between 33 and ABC. Let's call it 1 to 0. So we are going to say, hey, the index that we want to add is 0, 1, 2. So the index is going to be 2. It's going to be in place of ABC. The ABC will move forward. So we are going to say, hey, insert add, and the element is, let's say 1 to 0, and the index is 2. So that would mean that 33 would be here. ABC will push forward. So if I say okay, let's see what happens. So I'm going to play this out and you see that here we got 120. 33, 120, and then ABC. Now this looks good on the UI. What about the data structure? So if I go back to the data structure here, let's see what happens. We have got 22, then we have got 33, and then we should have 120. So if I open 33, you see that here the next item now points to 120. Super cool. This 120 should point to this new item or this old item ABC. So here if I open this, you see that 120 points to ABC. Super cool. This ABC should also point back to 120. That is really important because of being a doubly linked list. So if I open ABC, the ABC's previous property points back to 120. Hey, let's go. So we actually implemented the insert add completely fine. Now let's talk about the final function that we need to implement, that is remove add method. So for the remove add method, first of all, we need to establish that we need to return the removed element from this function, because that's what actually happens from this class as well, which is the linked list class. So if I say in the end, when we are removing the item, finally we send back the removed item, which here in this case is the current variable, but that doesn't matter. Now first of all, we are going to start with the constraints. So the constraints for this index is that we need to make sure that the index is not less than 0 and the index is not greater or equal to the size of it. And if that's the case, then we just return false here. Now, why would we do that? Because if it's less than 0, then that's an invalid index. But even if it's equal to the size, which means that we are saying there are 4 items and then the index is equal to 4, then there's nothing there because the last item always is at the index of size minus 1. So if there are 4 items, then the maximum index is 3. Here, this cannot be equal to the size. So we are saying greater than or equal to. So in both cases, we just return false. Easy peasy. Now, whenever we remove an item from the list, in most cases, we only need to find the previous element. But there could be cases where we also need to find the next element of the item being removed, because we have to fix the locks here, or so to say the pointers there. So first of all, we are going to get the previous item by doing super.getElement at index -1. So let's say if we are trying to remove the item at index 4, and let's say we have 10 items, so that doesn't matter. We need to get the element previous to the removed element so we can fix the patches in between, because if you remove an element from the linked list, there is a gap in the middle. You need to fix that gap by linking the remaining items together. So we are going to do exactly that. Now we get the previous item, we create a variable for the removed element, and then we return that removed element. Easy peasy. Now let's talk about the first use case. Let's say we're removing an item from the index 0. Now that would mean a couple of things. Once we have removed that item from the beginning of the linked list, there could be either the case that there are no items left now, which means the linked list is completely empty, or there could be the case that there are still items left. So let's see the UI and discuss what should happen in those two cases. Imagine that we only have one item in the linked list, and we can do that by just clearing the linked list and let's say adding an item that is 1, 2, 3. So if that's the case, then what we are talking about here is that we would be canceling this item. This will not exist anymore, which means that there will be no head, no tail, because they both would point to null. And we would also essentially have this situation where we would have the count equal to 0 as well. So if we remove a single item from the linked list, then we need to essentially make it just like we have the clear method here. So let's do that. So let's say if the index is 0 here, we are going to say that, hey, we are removing the first item from the linked list. Then we are going to remove that using the same method by doing super.removeAdd, and that would give us the removed element back. Now we need to say that if we have a case where after removing this item the size is 0, which means that the count is essentially 0, we have no items in the linked list anymore, then we say that the linked list now is empty. And then we can say that hey, the tail is now going to be null, because when we do this, in this case the remove add, you see that when the index is 0, we do a couple of things here. We reduce the count as well. We also make sure that the current is pointing to the right thing, and that ends up being the case that it points to null if it was the last item. The only thing remaining is that the tail is not set. So we are exactly doing that. There's no item left. We just need to make sure that the head and the tail, they both are pointing to null. So that's what happens in this case. Now let's talk about another case where the size is not 0, which means that the linked list still has some items. That is a fun part, because in that case we need to set up a couple of things. So what would happen in that case? Let's imagine that we are removing this item 22 from the linked list. That would mean that I'm going to remove this. Then the head is going to be 33 in this case, right? This 33 was pointing back to 22 before, but now it has to point back to null. And that is all that needs to happen. The head has to be changed, and the item that we have right now as the next of the current head, this should point back to null. So this pointer is essentially going to be fixed just like this. So let's check that in the code now. So once we have removed the item, we are going to say that the new head that we have right now, its previous pointer is going to point to null. That is what we just discussed, and that is all that we need to do. Nothing fancy. We just need to make sure that the item that we have right now, that is going to point back to null, because the head is already set here in this case, where you can see that when we use the remove add, it also, and we don't need to set the head here, because in the linked list file you can already see that we set the head to current.next when the index is 0. So we don't need to take care about that at all. Now let's try this out and see what happens. We are going to check both of the things. I'm going to first try out the case where we have no items left. So let's say we have an item called 123 that we are pushing into this linked list. Now if I try to say hey, remove element add, and here I say the index is 0, then let's see what happens. So if I click OK, you can see that the element removed message is here, and then we have the head and tail both pointing to null. But let's see the data structure. So here you can see that the count is 0, the head is pointing to null, and the tail is also pointing to null. So this is completely accurate. Now let's see that we have this case where we need to remove this head from here. In that case, the 33 would become the head, and then its previous is going to point to null. So if I say remove element add here, and then if I say the index is going to be 0, then let's see what happens. So if I click OK, see that the head is now 33, and if we look at this data structure, you see that the count has reduced from 4 to 3, and the head is 33. If I open the head, its previous is set to null. So this is working accurately without any issues. Now let's discuss what would happen if we had to remove an item from the end of this linked list. So in that case, it would mean that we are removing this XYZ from the linked list. And that also means that now we would have to fix the broken links. Right now XYZ points to null, but now that we have removed this one, this ABC's next pointer is going to point to null. That is what should happen, that we get the previous element and then we get its next pointer, set it to null, and that is pretty much it. We also reduce the count as well, but that is happening automatically in the linked list class. So let's fix that in the code now. So in the code, we are going to add another condition, and then we are going to say, hey, if the index that we are trying to remove is size -1, which means the last item or the index of the last item. So we do if index equals to size -1, then we are removing the last item from the linked list. And that would mean that we are saying that, hey, first of all, we are using the super.removeAdd. Here in the removeAdd, you will see that if it's not index 0, then what we do is that we get the previous element, we set the current to previous.next, and then we set the previous next to current.next. So this automatically does what we require. So in that case, the only thing remaining is that we also need to set the tail to the last item or to the previous item per se. So you already see here that we get the removed item, and we also got the previous item already in this variable. We could also have done something like previous item dot, or actually removed item dot previous. We could also have done that, but let's not go there. This code works flawlessly because we have the previous item already retrieved, and here we say that this dot tail equals to previous item. So that sets everything in the place. So here I'm also going to set one more thing, and that is the tails dot next, which means last item that we have right now, since it has changed, its next should point to null, right? Then we are good. So let's try this out in the browser now. So I'm going to refresh now, and I'm going to say, hey, remove an element at the last index. So the index are 0, 1, 2, 3. So I'm going to say, hey, this is the index, which is 3. Let's remove the item from there. So if I remove here, let's see what happens. Element removed. And now you can see that ABC has become the tail. Its next is pointing to null. So if I open the data structure, it should also be fine. So if I open this, you see that the tail is now ABC, which reflects accurately. And now if I open the tail object, you can also see that this ABC's next is pointing to null. So now we don't have any trace of the element that we just removed, which was XYZ. So now all the linked list items are pointing to the correct elements, 22, 33, ABC, and then we have null. Now, finally, we need to discuss what would happen if we needed to remove an item from the middle of the linked list. So in that case, we would have something like, let's remove this item like 33. Let's remove this guy here. So this would mean that now there is a gap between this linked list, because previously the 22 was pointing to 33, ABC was pointing to 33, and now this item is removed. So what would happen in this case is that now this 22's next is going to point to ABC. This ABC's previous is going to point to 22, and we are also going to reduce the count. So the count is going to become 3 because we are removing one item. So this exchange is what we need to implement. So let's do it now. So in the code, we are going to add another condition, and we are going to say that if it's not index 0, which means not the first item, not the last item, then we are doing something in the middle per se. So in this case, we are going to say, hey, first of all, let's remove the item at the particular index. So in that case, that 33 item is going to be removed. Then we get the previous item, which is 22, and say, hey, the previous item's next is supposed to be now the removed item's next. So we are saying that 22 is now going to point to ABC in that example that we just discussed. Similarly, we are supposed to say ABC is now going to point to 22 as previous. So we do that by doing something like this. We say removed element dot next, which means that 33's next was ABC. So ABC's previous should now point to 22. All right. And when we do so, we end up implementing the complete functionality. So let's try this out in the UI now. So now let's say we are removing this element 33. So I'm going to open my inspector, and here I'm going to say, hey, remove the element at index 1, which would remove this 33, and then 22 and ABC will be linked together. So here I'm going to say remove element at, the index is 1. I remove this, click OK, and you see that 33 is gone from this linked list. Now, if I open this object, the linked list object, you can see that the head is 22, the tail is XYZ, both accurate. If I open 22, this should point now to ABC because 33 has been removed. So if I open the head, you see that the next is pointing to ABC. So this is completely accurate. Now, if I open this next, which is ABC, this should point back to 22. So if I open this, you see that the previous is pointing to 22. Now that 33 element in the middle that we just removed, it does not exist in this entire linked list because we have 22, ABC, XYZ, and then the next is null. So we don't have anything. And that essentially is all the methods that we wanted to cover in this video. If you want to try out this further, feel free to explore because you can have multiple elements. Like you can see what is the linked list .to string. You get all the values from here. You can always check the size of this linked list. You can check if the linked list is empty or not, or you can remove an element by just providing its name. For instance, I could say something remove element, and here I can say ABC, and that removes this element from the linked list without even providing the index. And if you check this console log as well, you will find that now this 22 points to 33, points to XYZ, and there's no mention of ABC at all. So there are further functions as well that you can check out. And again, all of this is deployed to the GitHub pages. So if you want to play around with this, check this out visually, show off to other people to spread the knowledge, feel free to do so. And guess what? That actually wraps up our tutorial here, and it took me a lot of time obviously to build this, so I would highly appreciate if you can share this with others because I find this super cool because this is so visual, so others can also learn from this as well. If you want to hang out with me, I stream on Twitch every Wednesday and every Saturday. I also stream on YouTube and Facebook as well, so you can join on either platforms. If you're interested in understanding about Angular as a front-end framework, which is one of the best frameworks in the the world. It is backed by Google. It is amazing for enterprise projects. Check out my book that is called Angular Cookbook. It's doing amazing and has really good community adoption as well. And if you want to support this channel because you like the content, or let's say if you like me for some weird reason, then feel free to become a supporter as well. And let me know in the comments which algorithms or which data structures I should be covering in the next video. And as always, happy coding, and I'm gonna see you in the next one.